Hello everyone! Recently, I have been coding more of Super Sweeper, and we are currently on version 0.77.0. Now the cool thing about this version of the game is that it is actually compiled to run on Windows, compared to my previous video on Super Sweeper where I was running the game in an emulator. I made this version in SDL, and it runs between 35 and 990 frames per second depending on the scaling. Currently it's scaled to 2x, going from 320 by 240 to 640 by 480. There has been a few new features and refactoring in this version. One of my favorite additions is the menu screen. I have a program to turn a CSV file into the menu data, so I no longer have to manually type in everything. I learned how to do file access in C, which is nice so I don't have to deal with the signed integer to Java. I previously used Java to convert an image into the font, and for converting ASCII to the character set I use in the game. One of the nice features about using my own character set instead of ASCII is that numbers 0 to 9 map to indexes 0 to 9, making it a lot faster for some stuff. There are several other bug fixes and things I have changed under the hood since the last video. To get a virtual LCD to work in SDL, since, well, you can't just plug pixels to the screen in Windows like you can do on the calculator, I first had to change the defines I used, since 0xD40000 is the address of the VRAM on the TI-84CE, but it's probably somewhere that shouldn't be accessed on Windows. It probably will like crash and seg fault and yeah. Inside my frame timing function, I called a function to copy and render the contents of the VRAM. When the copy function gets called, it will copy a portion of the virtual VRAM to a buffer. The portion that gets copied depends on the frame base, which handles scrolling. If you can see here, I'll move some buttons and yeah, a different part of the screen gets shown. I also copy and convert the 16-bit palette to 24-bit RGB, storing the conversions in a lookup table to speed up the next step of the process. After everything is copied over, I get a texture pointer from SDL that I can write to. Then I convert the buffer's 8-bit pixels to 24 bits so they can be displayed in a window, utilizing the color lookup tables to speed up the conversion. I also coded in ways to handle dark mode and BGR mode, or blue, green, red, which is the reverse kind of RGB. The key inputs were a bit tedious to type as I manually copied defines into my code. I wrote conversion tables that will convert a SDL scan code to a TI key code. This conversion table also makes it easy to modify the keybinds, so I can have whatever wacky keybind I want to at any time. It's great. Additionally, I had to write replacements for some of the libraries, such as the timers. Then I had to convert the time to match the 32 kHz clock of the TI-84CE. The integer image scaling is done by repeating pixels and rows to make squares, kind of. Linear or cubic interpolation would cause blurriness, so I would use nearest neighbor scaling to cover non-integer scaling values, if I implement that at a later date. Alright, now a while ago on September 20th, 2022, I coded a Windows version of version 0.47.0 of the game using OpenGL. You can actually get it on Semitech, I have it uploaded there. It didn't run very fast at all, and I'm guessing it was like around 10 frames per second to copy the pixels to the screen. Although I will say it was quite easy to port the game as it was all in a singular C file back then because I didn't have header files or like literally anything. Just a long 2,000 line bit of code. It took until version 0.59.0 of the game before I started using .h files. I did not use GitHub until 0.66.0. So, yeah. I haven't been using GitHub for that long, but yeah, I'm glad it exists now. There is still a list of things I need to do before the game is complete. I'll have to finish scoring in the leaderboard, implement autosaving, coding in dot sliders to complete the quick game menu, getting the movie intro compressed, adding some graphical effects, and getting the hardware cursor to work. The hardware cursor is a bit of a tricky thing. It is a 64 by 64 2-bit image, making it hard to write to as it's not a multiple of 8 bits. But that is not even the worst of it, because Text Instruments really screwed up when making the TI-84CE. The LCD is actually a 240 by 320 portrait panel, but is driven as if it were a 320 by 240 landscape panel. This configuration causes issues such as this diagonal line effect and limiting the cursor to the leftmost 240 pixels. So it sort of worked, but I think the way I had it now, it kind of just crashed the calculator and stuff. The only way of fixing the issue would be for my game to run the LCD in portrait mode, but that would mean switching all the X and Y coordinates to counteract the rotation of the screen. Especially the hard-coded values that have remained untouched since at least version 16.0 from August 2022, so yeah, pretty old versions. It fit in like 4 kilobytes back then, I think. In the future, I hope to add graphical buttons to the Windows port, and some drop-down menus to change scaling, and experimental things such as a clock tick rate. Along with the video player that I have to emulate still because I haven't ported it to the Windows version yet. Didn't really want to handle the file conversions or file opening, whatever. Anyways, thanks for watching. I'll publish the updated version of Super Sweeper sometime soon. In the meantime, you can enjoy this collage of photos of the history of the game.